The first of these 8 modeling factors is reflected light. It is also sometimes called bounce light or indirect light. Here are 3 things I want you to remember. Distance matters, color matters, and angle matters. Take a look at the form shadow area of the cylinder. In a moment, I'm going to replace this piece of black paper with a green paper. The area of green light in the form shadow of this cylinder is an example of reflected light. I made this drawing when I studied in Florence. Here's a side view. The light is coming from the top and it hits all of the planes marked in yellow. Each of these areas will reflect light back. For example, reflected light from the chest will hit the neck and bottom of the chin. Reflected light is one of the most important tools in your toolbox for creating realism. Here is a little box floating in outer space. As we spin around it, put your attention on the form shadow. Now I'm going to remove the floor. And as we spin around this box, we can no longer see the form shadow. But can you see where the light terminates? Now watch what happens to the form shadow when we bring back the floor. This is the power of reflected light. Let's get a side view of this. The light is coming from the top left. It hits the floor and the top and front of the box. What I want to show you here is the effect of reflected light on the form shadow marked in pink. I've chosen 4 light rays for convenience. The reality looks more like this. There are potentially many light rays. Actually, there are also the light rays that miss the plane in the box. But this is really not a practical view. So let's stick with our 4 rays as a representation of many potential rays. Wherever light hits this floor, reflected light is generated. This is a diffuse reflection. And remember, light rays travel in straight lines. They can't bend like this. Now, let's follow the entire journey of one light ray. Ready? Step 1, incoming ray. This is direct light from the sun. Step 2, the first bounce of reflected light. Step 3, when this light ray hits the form shadow of the box, it will reflect again. And this is diffuse reflection, so there's a range of possible directions. The direction I'm interested in is this one. This ray hits the cast shadow on the floor. Let's replay this from a different perspective. Direct light coming in, first bounce, second bounce, and we will stop here. After a second bounce, the human eye usually can't detect any more differences. When you are considering reflected light, you can ask 2 very useful questions. Which surfaces are receiving direct light, marked in yellow here, and which surfaces are receiving indirect or reflected light, marked in blue. Look, it's the same as form light and form shadow. Reflected light mostly affects the shadows, including to a lesser degree cast shadows. It's very rare that you will see the effect of reflected light in an area that is already receiving direct light. And finally, look at the difference in tonal value between these 3 areas. Direct light carries all light energy. Then on the first bounce, the resulting value is significantly darker. Each bounce costs energy. After the second bounce, the light ray barely carries any light energy. In a moment, I will bring a white reflector into the scene. Focus on the form shadow of the box. Can you see how the influence of reflected light gets stronger as I bring the white surface closer. The shorter the distance that the reflected light needs to travel, the stronger is its influence. Now I'm going to cover the white reflector with a sheet of black paper. Again, focus on the form shadow area of the box. There's almost no reflected light left now. This means the local value of the reflector is really important. The local value is the brightness or darkness inherent in a material. Now let's switch the black paper for a green paper. The brighter the local value, the stronger the reflected light. You can also see that the green color is transported by the reflected light onto the box. Now about angles. Let's tilt the reflector, and as the angle becomes more and more shallow, the intensity of reflected light becomes weaker and weaker. This is especially important on curved surfaces. In this scene, the light is coming from above. It hits the floor and reflects back into the form shadow of the sphere. So we have reflected light mostly in the bottom right. The intensity of the reflected light is dropping off towards the top left, as the surface of the sphere is rotating away from the floor. In addition, the higher up on the sphere we are, the further the reflected light has to travel, and it also gets weaker for this reason. Angle matters, and distance matters. These two reasons give us the darkening of the core shadow. I said at the beginning of the video that many people confuse the Terminator with the core shadow. Can you see why? They're kind of in the same area. But the Terminator separates form light from form shadow. It's like a country border between Switzerland and France. But the core shadow is part of the area of the form shadow. It is created by the reflected light. If there is no reflected light, there's no core shadow. Look at the moon. There's no core shadow here because there's no reflected light. But there is a Terminator. Finally, to reinforce this point I made before, you can usually find reflected light only within the shadow family. That means form shadow and cast shadow, but almost never within the form light. Wow, that was a lot. How does your brain feel? I hope it feels stimulated. As a dessert, let's look at this drawing by Pierre-Paul Prud'homme. He chose to emphasize the core shadow. It's a bold choice, and it works very well. Usually it's a bad idea to separate the core shadow so much, but I think he pulled it off by making the entire drawing very harmonious. Even though the reflected light is strong, he kept the contrast within the reflected light very subtle. There's a lot of unity and harmony in this drawing, and that's why it works. Alright, now take a break, drink some water, and move your body. Next up, halftones. I'll see you there.